For billions of years, our solar system has been a silent island, floating in the vast ocean of stars. Planets, moons, and comets dance in predictable harmony, following ancient paths carved by gravity itself. But sometimes, something changes. Something foreign enters this celestial stage. In 2017, astronomers detected a mysterious object passing through our solar system. It was unlike anything they had ever seen. They called it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. It was the first known visitor from another star. 2 years later came another traveler, 2I Borisov, a true interstellar comet carrying gases and ice from a distant system. And now, scientists have discovered a third interstellar visitor, 3I Atlas. This object, detected in 2024 by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, has reignited one of astronomy's most fascinating questions. What lies beyond our sun's domain? And what stories do these cosmic wanderers bring with them? NASA scientist Dr. Karen Meech once said, "Every interstellar object is a time capsule, a fragment of another world, another sun, another history." 3I Atlas is exactly that, a fragment from the unknown. Unlike most comets that orbit our sun, 3I Atlas is not bound to it. Its trajectory is hyperbolic, meaning it will pass through and continue its journey into the void. Forever. It entered our solar system at incredible speed, over 100,000 kilometers per hour, moving along a path that cannot be traced to any known star. Its orbit tells a clear story. It came from outside our neighborhood. It came from interstellar space. When such an object appears, astronomers react quickly. They know they have only a few months before it fades from sight. Every observation counts, every photon of light carries data. Telescopes across the world turn their gaze toward this visitor. From Hawaii's Pan-STARRS Observatory, to the European Southern Observatory in Chile, to the James Webb Space Telescope orbiting beyond Earth. All watching, all recording, all asking the same question. What is 3I Atlas made of? Early data suggested it had a coma, a faint, glowing halo of gas and dust, typical of comets. But its brightness fluctuated unpredictably. Some nights, it shone brighter than expected. Other nights, it dimmed as if hiding behind a veil of mystery. NASA's Jet Propulsion Laboratory noted in a statement, 3I Atlas behaves like a comet, but not entirely. Its light curve suggests fragmentation or irregular rotation, indicating a highly active or unstable body. If that's true, then 3I Atlas may not survive its journey through our solar system. Like a cosmic snowflake melting under sunlight, it may dissolve, leaving only traces for us to study. But even if it vanishes, the information it leaves behind is priceless. Each particle of dust, each spectral line, each chemical signature, is a clue to the formation of other worlds. As ESA astrophysicist Dr. Gunther Hasinger remarked, interstellar visitors remind us that our solar system is not isolated. It is part of a galactic ecosystem, exchanging material across light years. Perhaps, one day, something from our own system will travel outward and become someone else's interstellar visitor. 3I Atlas is not just a scientific discovery. It is a story of cosmic connection, a reminder that the universe is alive with movement and exchange. From the silent depths of space, this icy messenger drifts past our sun, whispering secrets of creation. And as it disappears into the darkness once more, humanity listens, trying to understand what the stars are saying. In early 2024, a faint point of light appeared in the data collected by a system designed to watch the skies for danger. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, scans the heavens every night, searching for near-Earth objects that could pose a threat to our planet. But on that night, the software detected something unusual. Its motion was too fast, its path too steep, and its orbit could not be traced to the sun. Astronomers double-checked the observation. More measurements confirmed that this was no ordinary comet or asteroid. The object was traveling on a hyperbolic trajectory, meaning it was not gravitationally bound to our solar system. It came from interstellar space. The discovery was officially announced as 3I Atlas, the third known interstellar object after Oumuamua and Borisov. The 3i signifies its order of discovery, and Atlas honors the survey that found it. For the scientific community, this was a moment of both excitement and urgency. Interstellar visitors are rare and their appearance brief. Once detected, astronomers must act quickly to collect as much data as possible before the object disappears forever. Observatories across the globe began to coordinate. From Hawaii to the Canary Islands, from Chile to Australia, telescopes tracked the faint speck moving rapidly across the stars. Even space-based instruments like the Hubble Space Telescope and the James Webb Space Telescope adjusted their schedules to observe it. Dr. John Tonry, one of the lead scientists of the Atlas project, described the discovery with awe. He said, "It's as if we've opened a window into another star system, just for a moment, and something has drifted through." Early measurements showed that 3i Atlas was moving at more than 60 kilometers per second, nearly twice the average speed of comets that belong to our solar system. Its orbit was inclined, cutting across the plane of the planets, suggesting it came from a completely different direction in the galaxy. Researchers tried to trace its path backward through space, hoping to identify the system it came from. But interstellar space is a chaotic sea of gravity, and over millions of years, even a small tug from a star can alter a trajectory beyond recognition. The object's origin remains unknown. Spectroscopic analysis began almost immediately. By studying the light reflected from 3i Atlas, astronomers could infer its composition. Preliminary results hinted at a surface rich in volatile materials, ices of water, carbon monoxide, and perhaps methane. This suggested that 3i Atlas might have formed in the cold outer regions of another solar system, far from its star's warmth. As data accumulated, scientists began to notice something strange. The object's brightness varied in irregular ways. Sometimes it appeared brighter, as if venting gas or breaking apart. At other times it dimmed sharply. This fluctuation hinted that 3i Atlas might be unstable, perhaps already fragmenting under the stress of sunlight and gravitational forces. Dr. Karen Meach from the University of Hawaii, who also studied Oumuamua and Borisov, noted, "Each interstellar object tells a different story. Oumuamua was dry and rocky, Borisov was icy and comet-like, and now Atlas seems to be somewhere in between." This diversity puzzled astronomers. Why are these visitors so different if they all come from beyond our sun? The answer may lie in the variety of planetary systems scattered across the Milky Way. Each star, surrounded by its own mix of planets, asteroids, and comets, creates unique debris. When something is ejected by a gravitational encounter or stellar event, it becomes a wanderer, drifting endlessly between stars. As the weeks passed, 3i Atlas grew brighter, reaching its closest approach to the Sun. It was visible only through telescopes, a small streak against the black canvas of space, but for scientists, it was a cosmic messenger bringing a story from a place we will never visit. Every night, teams across continents shared their findings, comparing spectral lines, trajectories, and light curves. Each observation was another piece of the puzzle. Some data hinted that the object might be shedding material rapidly, perhaps even disintegrating. If true, it meant that 3i Atlas could vanish entirely before leaving the solar system, scattering dust that would soon fade into darkness. Dr. Avi Loeb from Harvard University commented on the discovery, saying, "The fact that we are now detecting multiple interstellar objects in such a short time suggests that these visitors might be far more common than we thought. The galaxy could be full of wandering debris, silently crossing between stars." For the scientific world, 3i Atlas was more than a single object. It was a confirmation that interstellar travel, not by spacecraft but by natural fragments of other worlds, is an ongoing process. The solar system is not isolated. We live in a galaxy where matter, dust, and ice constantly move between the stars. And as 3i Atlas continued its journey toward the outer reaches of the solar system, astronomers knew that every night of observation brought them closer to understanding how worlds are built, how they die, and how pieces of them may one day visit us. The discovery of 3i Atlas marked the beginning of a new era, an era in which the boundaries between solar systems no longer feel distant, but connected by the invisible currents of the galaxy itself. Every interstellar object carries information about the system that created it. The atoms, ices, and minerals within it are shaped by the chemistry of another sun. To study 3I Atlas was to hold a piece of an alien world. Observations began in visible light, infrared, and radio wavelengths. Each band of light revealed a different layer of its nature. In visible light, it appeared as a dim, bluish dot surrounded by a faint haze. Infrared analysis showed the presence of volatile ices, substances that vaporize easily when warmed by sunlight. Among them were traces of water ice, carbon dioxide, and carbon monoxide. These are the same materials found in comets from our own solar system. But the ratios were different. The chemical fingerprint of 3I Atlas did not match anything known locally. This hinted that it was born in an environment unlike ours, possibly around a cooler red dwarf star, where temperatures are lower and ices can form closer to the star. Astronomers also measured how the object rotated. Its brightness fluctuated irregularly, suggesting that it was tumbling in multiple directions rather than spinning steadily. Such chaotic rotation is typical of small bodies that have been through violent events, like collisions or gravitational encounters. If 3I Atlas was ejected from another system, it might have been torn from a young planet-forming disk, thrown outward during a close pass with a giant planet or a dying star. Its shape, though too small to resolve directly, was estimated from its light curve. Most models suggest a fractured or elongated body, possibly several hundred meters in diameter. Spectroscopic analysis from the European Southern Observatory revealed another surprise. The ratio of carbon to oxygen was higher than in solar system comets. This indicated that 3I Atlas may have formed in a region rich in carbon-based compounds, a place where organic molecules could develop in abundance. Dr. Michela Battisti, a planetary scientist from the Max Planck Institute, commented, "Objects like 3I Atlas are laboratories of chemistry from other worlds. Each one gives us a sample of environments we could never reach, except through these travelers." As sunlight struck the comet, it began to sublimate, releasing gas and dust. These emissions created a thin atmosphere, a coma, around the nucleus. Astronomers measured how fast the gas escaped and how it interacted with the solar wind. The data showed that 3I Atlas was highly active, losing mass rapidly as it approached the Sun. Some researchers proposed that this activity might cause the object to fragment entirely, as pressure from within overcame its weak structure. Others suggested that the erratic brightness could result from jets of gas venting in different directions, making it spin unpredictably. NASA's Planetary Defense Coordination Office published a statement explaining, "The study of 3I Atlas gives us insight into how interstellar bodies behave under solar radiation. These observations help refine our models of cometary evolution and destruction." One of the most fascinating findings came from infrared spectroscopy performed by the James Webb Space Telescope. It detected complex organic molecules, long chains of carbon and hydrogen similar to those found in the primitive material of the early solar system. These compounds are the building blocks of life. Their presence suggested that the processes forming organic chemistry are not unique to our system but may occur throughout the galaxy. Dr. Karen Meach summarized this discovery simply, "Life's ingredients are everywhere. If they can form on comets around other stars, then the seeds of life may drift between worlds." 3I Atlas thus became more than just an icy fragment. It became evidence of a universal pattern, matter combining and recombining across cosmic distances, forming molecules that might one day give rise to life. Another key focus of study was its speed and trajectory. By measuring its motion relative to the Sun, astronomers found that it entered the solar system from the direction of the constellation Lynx. After passing the Sun, it would exit toward the constellation Hydra, never to return. Its hyperbolic excess velocity, its speed after escaping the Sun's gravity, was around 25 kilometers per second. That is fast enough to cross the distance between stars in a few million years. These measurements confirmed that 3I Atlas was a true interstellar object, not a comet perturbed from the distant Oort cloud. Its orbit could not be explained by any known solar system origin. For scientists, this discovery reinforced a growing realization. Our galaxy is not a static collection of isolated systems. It is a vast network of exchange. Fragments of one world can travel to another, carrying with them the chemistry of their birthplace. As astronomers compiled their data, they saw that 3I Atlas was both familiar and alien. It shared traits with comets we know, yet it spoke of conditions far beyond our sun's influence. It was a messenger carrying chemical whispers from another star, crossing the boundary between worlds. The study of 3I Atlas opened a new chapter in planetary science. Each observation sharpened our understanding of how common materials like ice, dust, and organic matter behave across the cosmos. And each measurement reminded us that our solar system is just one of countless laboratories of creation. The science behind 3I Atlas revealed a simple truth. The universe recycles itself. Stars form planets. Planets break apart. Their fragments travel the galaxy, sometimes finding their way to new suns, new systems, and new beginnings. The next question was inevitable. If fragments like 3I Atlas carry organic material, could they also carry the potential for life itself? To explore that idea, scientists turned to one of the most profound concepts in astrobiology, panspermia. The discovery of 3I Atlas sparked a wave of discussion across the global scientific community. As data poured in from telescopes and space observatories, astronomers and astrophysicists began to ask deeper questions. What exactly is this object? And what does its presence mean for our understanding of the galaxy? From the start, there was broad agreement that 3I Atlas was a comet-like body. Its coma, its vaporizing ices, and its chemical signature all pointed to a natural origin. Yet, as with its predecessors, Oumuamua and Borisov, certain details refused to fit perfectly into the models. Some scientists proposed that 3I Atlas could be part of a much larger population of interstellar debris ejected from developing planetary systems. According to Dr. Michelle Bannister of the University of Canterbury, every newborn star system throws material into interstellar space. Over billions of years, those fragments become the galaxy's drifting population. They are as common as grains of dust, but only a few ever wander close enough for us to see. This view treats 3I Atlas as a natural byproduct of cosmic evolution, a messenger of ordinary processes on a grand scale. But others wondered whether the object might carry traces of something more unusual. Harvard astrophysicist Dr. Avi Loeb, who gained attention for suggesting that Oumuamua might be artificial in origin, commented carefully on 3I Atlas. He said, "We cannot assume that every interstellar object is natural. If the galaxy produces billions of fragments, some could easily be technological debris, remnants of civilizations long gone." He emphasized that while there is no evidence that 3I Atlas is artificial, it is important to remain open to all possibilities until data rules them out. Most astronomers, however, favor natural explanations. Dr. Loeb's ideas remind the community that the extraordinary sometimes hides in the ordinary, but the consensus remains scientific. 3I Atlas behaves like a comet, and its properties can be explained through physics and chemistry. Still, debates continued. Some researchers focused on the object's brightness variations. Was it simply fragmenting, or could its reflective surface hide something else? Its rotation was irregular and unpredictable, a sign that it was not a solid monolith but a fragile body, perhaps breaking apart as it traveled. This instability made detailed observations difficult, leaving gaps that invited speculation. Astrophysicist Dr. Alan Fitzsimmons from Queen's University Belfast explained, "We must resist the temptation to fill unknowns with imagination. Nature produces strange results all the time, and interstellar objects are examples of processes we've never directly observed before." Another mystery concerned the origin of 3I Atlas. Efforts to trace its trajectory backward through space produced no clear result. It did not appear to come from any known nearby star. Over millions of years, gravitational forces from countless stars would have distorted its path beyond recognition. All that could be said for certain was that it came from somewhere in the galactic disk, perhaps hundreds of light years away. A few models suggested it could have been ejected from a binary star system. In such systems, complex gravitational interactions can throw comets into interstellar space. Others propose that it might be a remnant from the early days of its home system, a piece left over from the birth of planets. The European Space Agency's Dr. Gunther Hasinger summarized it this way. 3I Atlas represents a bridge between solar systems. It connects our chemistry with the chemistry of other stars. Its exact origin may remain unknown, but its existence confirms that material exchange is a fundamental process of the galaxy. While astronomers analyzed its spectrum and motion, philosophers and astrobiologists reflected on a deeper implication. If objects like 3I Atlas are constantly traveling between stars, then the boundaries between solar systems are not barriers but pathways. The galaxy becomes a living network of material transfer, a circulation system of dust, ice, and molecules that could, under the right conditions, carry the ingredients of life. Dr. Sara Seager of MIT noted, "The more we study interstellar objects, the more we realize that our solar system is part of a continuum. Nothing in space exists in isolation. Even the smallest piece of dust has likely traveled through multiple stellar neighborhoods." This interconnected view challenges the way humanity once imagined the universe. The solar system is not a closed world but a node in a vast, dynamic web. Each interstellar visitor, from Oumuamua to Borisov to Atlas, is a reminder that creation is not confined to one star or one planet. And yet, the debate over possible artificial origins has not faded completely. The search for extraterrestrial intelligence often intersects with such discoveries. Even though no signals or unusual emissions have ever been detected from 3I Atlas, some researchers argue that studying these objects with advanced instruments like the Square Kilometre Array or the James Webb Telescope could one day reveal signs of technological material drifting between the stars. For now, 3I Atlas remains a natural mystery, fascinating but consistent with what science can explain. Still, its story has expanded our curiosity. It reminds us that exploration is not just about what we discover, but about the questions we dare to ask. In the end, every theory about 3I Atlas, whether natural or speculative, leads to the same profound thought. If fragments of other worlds can reach us, then perhaps, somewhere in the depths of space, pieces of our own planet are already on their way to another star. This idea leads directly to one of the most intriguing possibilities of all, that life itself might travel between worlds, carried by comets and interstellar debris. The next chapter explores this ancient and daring hypothesis, the theory of panspermia. For centuries, humanity has looked to the sky and wondered where life began. Did it arise here, on Earth, out of the chemistry of our oceans? Or did the first seeds of life drift to us from the stars? This idea, that life might travel through space moving from one world to another, is known as panspermia. It is one of the oldest and most fascinating scientific hypotheses ever conceived. The term comes from Greek, pan meaning all, and sperma meaning seed. It suggests that the seeds of life are scattered throughout the cosmos, waiting for the right conditions to take root. While the theory sounds poetic, it is grounded in real science. Comets, asteroids, and interstellar dust all contain complex organic molecules, the building blocks of life as we know it. Among these are amino acids, sugars, and carbon-rich compounds, the same ingredients found in every living cell on Earth. In 1969, a meteorite fell near the town of Murchison in Australia. When scientists examined it, they found more than 70 different amino acids, many not found in Earth's biology. It was a revelation. The chemistry of life was not unique to our planet. It was cosmic. Comets like 3I Atlas may therefore be more than icy wanderers. They may be couriers, carrying the materials of life across the galaxy. Each time one passes near a star, heat releases these compounds into space, spreading them farther still. The late British astronomer Sir Fred Hoyle, one of the most famous proponents of panspermia, once said, "Life is a cosmic phenomenon. It is not confined to the Earth. The seeds of life are everywhere, carried by the winds of interstellar space." Hoyle, together with his colleague Chandra Wickramasinghe, proposed that comets could serve as incubators for microbes, protecting them inside layers of ice and dust, allowing them to survive long journeys between stars. While their version of panspermia remains controversial, later discoveries have given parts of it renewed credibility. Laboratory experiments have shown that certain microorganisms like bacterial spores can survive in extreme conditions, even the vacuum of space. In 2015, scientists aboard the International Space Station found that tardigrades, tiny microscopic animals, could live through cosmic radiation and near absolute cold for years. If simple organisms can endure such extremes, then perhaps life could hitch a ride on rocks or comets traveling through the void. NASA's missions have added to this evidence. The Stardust spacecraft, which collected samples from Comet Wild 2, brought back organic compounds that had formed in the cold regions of space, molecules older than the solar system itself. And in 2014, the Rosetta mission confirmed the presence of complex carbon molecules on Comet 67P Churyumov-Gerasimenko. It was another sign that comets are chemical laboratories, places where the ingredients of life naturally assemble. So what does this mean in the context of 3I Atlas? If this interstellar visitor contains similar organic molecules, it might represent the same process, not just between planets but between entire star systems. It could be a fragment of a long-lost world, or the frozen remnant of an ancient disk of life-bearing material. Astrobiologist Dr. Paul Davies of Arizona State University describes the possibility this way. If panspermia is real, then the universe could be full of life, connected through an unbroken chain of cosmic exchange. Life on Earth would not be a local accident, but a continuation of a universal process. This perspective transforms how we see ourselves. It means that the DNA in our cells might carry a heritage older than the Earth, a molecular memory of other suns and other skies. Every living thing, from the smallest microbe to the human being, could be part of a galactic lineage stretching back billions of years. However, not all scientists accept panspermia as the answer. Critics point out that, while organic molecules can survive space, living cells would face intense radiation and long travel times that make survival improbable. Still, even these skeptics agree that the chemistry of life is universal, and that comets and interstellar objects help distribute those molecules everywhere. Dr. Carolyn Porco, who led the imaging team for the Cassini mission, once said, "The ingredients of life are written into the very dust of the cosmos. What we're seeing is a universe naturally inclined toward chemistry that can lead to biology." So whether or not panspermia explains how life began on Earth, it has reshaped the way we look at comets like 3I Atlas. They are not just icy relics of creation. They are part of a living story, one that connects the origin of worlds to the possibility of life elsewhere. Every interstellar visitor that passes through our solar system brings with it the potential to teach us more about that story. Perhaps somewhere out there beyond the reach of our telescopes, another world is watching its own version of 3I Atlas pass by, carrying, unknowingly, the same cosmic material that once gave rise to us. And in that realization lies a profound truth. The universe is not silent. It speaks in chemistry, in stardust, and in the quiet migration of comets through the dark. As we turn our gaze back toward the stars, the next question arises: what does this all mean for humanity's place in the cosmos? If we are connected to the galaxy through matter, motion, and memory, how should we see ourselves in this vast interstellar web? 3I Atlas is more than an icy visitor from another star. It is a reminder that humanity exists within a vast, interconnected universe. Our solar system is not an isolated bubble. It is a node in a complex network of matter, energy, and time, stretching across the galaxy. Every comet, asteroid, and interstellar object tells a story. Each one carries the chemical history of its origin, the frozen remnants of distant suns, the dust of worlds we will never see. By studying them, we glimpse the processes that shape the cosmos and perhaps the very origins of life. For humans, this knowledge is humbling. It shows that we are small in space, yet part of something unimaginably large. The atoms in our bodies were formed in the hearts of stars billions of years ago. The same cosmic processes that created distant comets like 3I Atlas also shaped our own planet and everything upon it. 3I Atlas also inspires curiosity and exploration. It challenges us to look beyond Earth and imagine the possibilities of the universe. We are compelled to ask questions about life, creation, and our role in the cosmos. It reminds us that science is not just about understanding facts, but about seeking meaning in the unknown. Dr. Avi Loeb once said, "The universe is vast and full of surprises." Objects like 3I Atlas teach us to keep an open mind and to prepare for discoveries that may challenge our assumptions. The presence of interstellar objects also hints at a profound connection between worlds. If matter and possibly life can travel across light years, then the boundaries we see are not walls but bridges. The galaxy is a living system, exchanging material and information across unimaginable distances. From a philosophical perspective, 3I Atlas invites reflection. It encourages us to consider that life on Earth may be part of a larger galactic story. We may be recipients of cosmic visitors, and perhaps one day, we too will send our own fragments into the void, carrying the story of our existence to other worlds. For humanity, there is both humility and hope. We are tiny observers in a galaxy of wandering objects, yet our intelligence allows us to perceive, understand, and even participate in the ongoing story of the universe. 3I Atlas reminds us that science and imagination are inseparable. Through observation, measurement, and contemplation, we connect with the infinite. As 3I Atlas continues its journey beyond the reach of our telescopes, it leaves behind knowledge and inspiration. Its passage encourages scientists to look deeper, ask broader questions, and consider the vast possibilities that lie beyond our solar system. In the end, the meaning of 3I Atlas is not simply in its chemical composition or trajectory. It lies in what it represents: the boundless curiosity of humanity, the interconnectedness of the galaxy, and the profound realization that we are part of an ongoing cosmic story. Every interstellar visitor is a messenger, carrying secrets across the void. And as we continue to watch, measure, and learn, we honor the universe by seeking understanding, by acknowledging our place, and by embracing the infinite journey that connects all matter, all life, and all stars. 3I Atlas has passed through our solar system, but its lessons remain. It reminds us that the universe is vast, dynamic, and alive with possibilities, and that, in observing the heavens, we are, in a small but meaningful way, observing ourselves.